Okay, we're going to go over how to move objects around without physics, so how to like manually move things in directions. Now you could do this in two different ways. I'm going to do it moving the transform right now. However, absolutely you could do it with the rigid body also. In a lot of cases that's better, and I'll kind of talk about that at the end of the video. So all I've done here is I've created a totally new scene, which is, it's called sample scene. So I've created sample scene and it's literally empty other than I've imported some sprites that I can use, but as of right now my scene is empty. Okay, so what I'm going to do is I'm going to pull in a rocket ship because I'm going to do some bird's eye view flying around. That one's a little too big. Now I could just change the scale, you know, I could make it wider, so I could set all these to 0.5 and so it's smaller, but I like to leave all of these at their original. So I'm going to reset this, leave it as scale factor of 1. But instead I'm going to go into where it's actually imported. And I'm going to change this more to a resolution like 200, which means draw it smaller. So more pixels per unit in the game. So I'm going to go ahead and apply that. Oh, I clicked the wrong button there. Sorry. I didn't mean to click sprite editor. I meant to click apply. So after I put in, let's say 250, let's click apply. Boom, I drew it. That's a perfect size now. All right, so as of right now, my rocket ship is nothing. It's just a position and an image. So I'm going to go ahead and create a script. So let's create a folder here called scripts. Let's go in there. I just hit enter twice to go into there. So I'm going to create a script called RocketController. Okay, now I'm going to hit enter again just so it opens up in MonoDevelop. Now, I'm only going to write a few lines here. I'm going to do a really simple version of how to move this using the transform. So what I'm going to do is I'm going to say, okay, inside the update function that's called once every frame, let's get the horizontal input. So horizontal input, I'm going to get input.getAxis, and then from the horizontal. So that gets whether the user is pressing right or left on whatever input is plugged in. So that could be left and right arrows, or A and D keys are the default on a keyboard, or if they plug in a joystick, that would be detected on the corresponding joystick. Okay, now this is giving me a decimal between -1 and 1. I'm going to do the same thing for vertical, so vertical input, and I'll do input.getAxis for the vertical. Okay. So now I've got whether the user's pressing some buttons. So what I want to do is I want to create a vector out of that. So if they're pressing right, I want an arrow pointing to the right. If they're pressing up, I want it pointed up. If they're pressing right and up, I want it pointed up and to the right. Okay, so what I'm going to do now is I'm going to create a new vector 3. Now I could create a vector 2, although since transforms are all vector 3s, in other words, they have an X, a Y, and a Z, it's easier in general to stick with vector 3s for everything, or at least I find it easier. So I'm going to create something of the type vector 3. I'm going to call it my direction vector, give it a nice clear name. And so since this is from the vector 3 class, I need to create a new object of vector 3 type, and in the constructor I'll put in the numbers I want. So my new vector will have the X and Y left and right of the input I just took in up here. So I'm going to type that here, horizontal input. And then the up and down, the Y, is going to be this input I just got called vertical input. And then the Z, which goes directly into the screen and directly out of the screen, I don't want any direction in that direction. I want it to stay flat in that 2D world. So there's now a direction pointing where they're pressing buttons. If they're pressing right, this is 1, 0, 0, and that's pointed directly to the right. If they're pointed up, it's 0, 1, 0, and so accordingly. All right, so now I want to use that in two ways, okay? So first, I'm going to say, take my current position, okay? And so going back to Unity, I'm saying of the transform, look at the position. So there's an X, a Y, and a Z. This is a vector 3. And I'm going to set it to my current transform position plus the direction vector. Okay, right there. So I'm just saying take my current position and add this arrow. So it'll take me one step in that direction. We could get into the length of that vector a little later. I should normalize it, but we're not worried about that right now. Okay, I'm also going to rewrite this same thing of itself plus something. I'm going to shorten that to plus equals. Okay, so that's saying take my position, add direction vector, that's the new value. Okay, so I can save this as is. I can go back over here. No, I have no control over the speed. And as of right now, I haven't even attached the script. So I'm going to attach the script to my rocket. I have no control over the speed, so this might be too fast or too slow. But whoa, that was fast. Okay, so I want to slow that down a little bit. That's just a little much for me. So I'm going to click play. I'm going to go back over here, and I'm going to add a public float, so decimal, and I'm going to call it my move speed. Okay, so I'm going to multiply this by my move speed. Okay, now there's one other thing going on here. This is happening every frame. That's kind of independent of time. So 1 second might have 80 frames and another second might have 5 frames. Now that's an extreme difference, but you don't want things to depend on how often the frames are called. So what we do, and it's okay if this is a little complex for you now, is we're going to, referring to the time class, we're going to say multiply this by time.delta time. And that's the time in which it's taken since the last frame. So since the last update was called, how much time has passed? And what that allows you to do is, if it's choppier, so there's only maybe, say, 5 frames per second, then you are going to travel 5 times as far. Whereas if there's lots of small frames, you will travel small distances, and this will essentially keep our movement linear. So it will, if regardless of frame rate, it will travel at a constant speed. Even if the frame rate goes high, frame rate goes low, using the time in between frames will just let you travel at a constant speed, regardless of 30 frames, 20 frames, 40 frames. Okay. So let's save this. Now I've multiplied by a move speed, but I haven't set it. So going into Unity, I'm going to change the value of 0 that will pop up here in a second. I'm going to change that to 1 to start. I'm going to enter play mode, and let's see what happens. Oh yeah, that's too slow. Now that I'm using that time.delta time. So let's play with this in here. So I'm going to go up to like 5. Oh, that's a little better. Okay, maybe I'll exit play mode, and I'll just set this to a nice 7, okay? So I've got my movement. Let's check some up and down all around. Oh yeah, that looks good, except I want this to rotate, okay? I already have the direction I want it to point in, right? So going into here, I know I want it to point in this direction. So a really simple way to do this, not getting into the trig or the inverse, like the arctangent to calculate direction, a really simple way to do that is just to say, I want to take the transform.right. So this is in the game, this is the right direction of this game object. So the right direction is pointed over here off to the side. And I'm going to say take that direction and point it in this direction. Okay, I'm going to save that. I'm going to go back into Unity and I'm going to click play. Okay, so now when I press right, it goes right, up, it goes up. When I don't press anything, it resets to 0. Again, we could deal with that later. Left goes left, down, and now I can fly my ship around. And it's not perfect, but that's a great beginner script here. Just talking about getting the left and right, up and down inputs, creating a vector in that direction, and then using that to both move and point the thing in a direction. Okay, now I've specifically used this with the transform and done it all in the update method. If you're going to be using this to collide with other objects, it's often better not to directly manipulate the position of transform, but instead use the rigid body, as if you tell the transform go over 1 unit, it might go through a collider, place your object inside a collider, or travel straight through a collider. So rather than forcefully telling the transform, go to a new position, you could do the exact same thing with the rigid body class. So we don't have one right now, but just if we use, like let's say my rigid body 2D, I could then do dot I think it's move. You don't even have to do add force where then you use gravity. You can actually just move positions around the screen. You can set the position, you can set the velocity. So you can do these same mechanics using the rigid body. I just wanted to show you some basics with the transform. Now, we could still detect collisions over here. If I just wanted to bring in another game object, let's say I want to bring in this asteroid right in front, or let's even put it up here, okay? Now, for a collision to happen between these two things, they both need to have a collider. So I'm going to go physics 2D, circle collider. That's close enough. I'm going to go add a physics 2D box collider. That's close enough. Now, again, for this collision to happen, you'd think that would be enough. Like they both got a collider, but A, they go right through each other, and B, if I tried to use on collision enter 2D, nothing would happen. So this is where that using the rigid body is helpful, where they bump into each other. But also, collisions are only detected with the rigid body class. So if I want collisions to be detected in this game, I would still have to add a rigid body 2D. And then I could just say, don't even simulate gravity. Or I could just turn off the gravity. I could set the gravity scale to 0. Okay, so I can go in here. I can do this, and now it'll actually detect the collision. See how I move through it and go back? I'm sorry, I made a mistake there. If I say don't simulate, then this won't even do anything. It won't detect the collision. So that was my mistake. In 3D, there is a use gravity checkbox, and I got mixed up. So you definitely want the rigid body to be running and making calculations. But you can set the gravity to 0. And then what I could do is I could go into my Rocket script or my Rocket controller. And so, it's already open. So in my Rocket controller, I could just go down here and go void on collision enter 2D. That will make a collision 2D object. I'm going to call it other. And then in there, I'll just say debug.log hit the asteroid. Okay, and let's just see if that gets called. So we're not even using the rigid body for any gravity, for any motion, but because we've included it and a collider on both, I can still have it detect. I think I saved that. I can still have it detect that I hit the asteroid, right? And I click back on my game scene so I can move, and I go do 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 boom, do 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 boom, do 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 boom, boom. So there's a basic way to move a character around and detect some collisions. Again, you need a rigid body on one of the two things that is being simulated, although you can set the gravity 0, but you need a rigid body and a collider on both things. Okay? Other than that, hopefully you enjoyed this. I'll save the project and I'll put it all up under the YouTube video.